Okay, we will continue with the type of layout, but this time is under the manufacturing, okay, or plant. The first one we look at the fixed position layout. Okay, just I told you that usually this one is for bulky item. For example, construction of a building, okay, at the shipyard, okay, building a ship, and also for service, we also have a fixed position layout. For example, in the operation room, okay, in the OR, so you cannot move the patient around. Okay, so this one is also considered as a fixed layout. Okay, the product remain at one place. Okay, and then workers or equipment come to the site. For example, the workers, the crane, all the material coming to the shipyard, and also same goes for the construction of a building. They going to the construction site. The complicating factor, they have a very limited space at the site. Yep, that's true because it's so big. And then they need to have a very good scheduling on the in and out of the material, and also for the workers. Okay, they must have a good scheduling. They cannot put all the material at one place because they have a very limited space. And also they need to make sure that the stages of the project it's going smoothly, because if not, they will cause lots of trouble if they have lots of material at the site. Okay, because the space are very limited. Okay, alternative strategy. Okay, if you have a very limited space, for example, you do by module. For example, to build an airplane, for example, for Boeing, all the fuselage, okay, the wing, and also the other equipment is done by module. Okay, and then they will ship it to the factory to assemble. Okay, to assemble as a uh, one aircraft. So they don't do it at the assembly site. So they bring all the modules, okay, the cockpit and so on, and they will assemble in the factory. And they call it off-site. Okay, they do the module off-site and assemble. Same goes for house. Okay, nowadays they assemble module by module. Okay, so maybe they done the roof. Okay, and then they move it to the assembly site. Okay, but it will cost a lot on the transportation because the module is quite bulky. Okay, but it's still doable and also efficient if you have a very limited space on the assembly site. Okay, the next one is the process oriented layout. Okay, we look at the fix, and then we look at the process oriented layout. For example, machine shop. Okay, and then for service, we look at the hospital or bank. Okay, bank also have a process layout in which different customer have different service that they want from the bank. Okay, and machine equipment are grouped together. For example, in hospital, all the X-ray machine in the imaging department. Okay, all the uh, ultrasound machine is on the other department. So all department have their own machine and equipment, and also they have the special personnel to handle all the equipment. Okay, scheduling can be difficult. Okay, because it's flexible. If you go to the hospital after the doctor diagnose, sometimes you need to go to X-ray, but sometimes you just need to go to the other department. So it's hard to know actually where are the next process going to be. And it's a very customized product or service. Okay, for example, in hospital, if you have accident and then you go to emergency, and then you have to go to X-ray and so on. And then sometimes you go to the hospital for a minor fever, so you don't need to go for X-ray, and then you can go to see the doctor, and you can get the medicine from pharmacy, and you are off. So they have a different process for different customer. Okay. Okay, this is an example in the hospital. Let's say you arrive at the emergency, okay, broken leg, and then you go to ER, and then you go to radiology for X-ray, and then surgery if you need ER bed, pharmacy, and billing. Okay, and then if you have a different problem, so you go. Sometimes you don't need to go to radiology for X-ray. You go straight to the pharmacy, and then you go to ER, and then you go out. So they have different uh, customer with a different process. Okay, there's a method in the arranging or the to arrange the layout for process oriented. This is one of the method. Okay, they use this method based on the number of loads or people moving between the center and also the distance. Okay, they are considering these two factors, and they have this formula in terms of cost. So they are trying to find the minimal or the minimum cost as possible. So they want to arrange the workstation. And it can be done in the software also. Okay, these are the software that specialize in the layout for process oriented. Okay, so they will give you the minimum cost. Okay, so using graphical, and then they can compute more complicated problem. Let's say you have like 12 departments, so how are you going to arrange it? So they are using this software. Okay, these are the example of the software. They do it for you. And also they use the 3D visualization software. Okay, for example, okay, this one is before you do the layout, the layout, so you know, okay, this what is the distance between the robotic arm and the other line? Is it safe to move in between? Is it safe for the maintenance to go in? So you can visualize all this, especially if you need to involve with the material handling. Let's say you want to install conveyor belt, if you want to have forklift to come in between this area, so you need to do this simulation. Okay, so you have the idea on the efficiency and safety issue that you need to consider. Sometimes if you do it in 2 dimension, you will not get the overall picture, but when you did it in the 3D, so you know what are the constraints in the design. Okay, the next one is the work cell. Okay, work cell is organized people and machine into groups, and those group will produce parts. Okay, similar parts, and usually the volume based on the cell itself. Okay, advantage of work cell, it's reduced work in process inventory, means that each cell will deal with the work in progress. So usually they have the raw material and they produce until the finished good and then move to the next station. And less space required because they they sit in the cell. Okay, and then they reduce the raw material and finished good inventory, in which only parts that needed that they are sent to the cell. And they reduce labor costs because sometimes one workers can do up to 3 or 4 tasks in the cell, and it can increase the equipment and machine utilization, and also it give a feel of teamwork among the workers working in the work cell. Okay, requirement of work cell: identification of family product. Okay, and high level of training and flexible of the employees, in which all the employees in the work cell can do each other work. They are flexible. Okay, they are cross trained. And also each cell will control their quality, so they make sure that all the product within the spec, and then after that they will move to the next work cell station. Okay, for example, okay, before this the workers work, they're sharing the same material, so they are turning. Okay, they do lots of turning and very close. It's a very close area, so they have to move, okay, to turn, okay, front and back, just to get the material and go through towards this process. Okay, so when they rearrange into cell type, so what they have to do now is don't have to go to turn around. They just take the material in the middle, so they go through the process and finish up at this site for this person. And same goes for this person, raw material in the middle, go through all the process and end up here. Okay, so the workers can assist each other if they need help. Next, we can see that before we have a straight line, so you'll have lots of space. Okay, and then maybe the work is not evenly distributed. So maybe this worker alone here, so these two are very fast, so maybe there's bottleneck here. So if you make it into a U shape, so you need only 3 workers to handle it. Okay, so this worker can assist both two. Okay, these 2 workers. So U-shaped line may reduce employee in movement. So if this 2 person need help, he will need to walk across here. But in the U-shape, he will do the less movement, okay, to help these 2 workers. Okay. In terms of U-shape, it help it's a better access and also a space saving. So for example, okay, staffing work cell example. So let's say this is a mirror factory, okay, mirror for the automotive. So 6 mirrors per day are required. Okay, that's the target output. So mirror production schedule for 8 hours per day. So means that in 8 hours they need to produce 600 mirrors. So from this uh, the from this chart, okay, we know that there's 1, 2, 3, 4, 5. There's 5 tasks. And each task, it's they have the duration here, so 50 seconds. Okay, for the first task, second task 45, 10, 20, and 15. Okay, this is the time that we need to complete 1 mirror. So for this one, the total time needed to complete 1 mirror is 140 seconds. Okay, so how many workers we need? Okay, for this process. So the takt time is, okay, the takt time or the time to make 1 unit of the mirror is 8 times by 60, okay, and divide by 600. So we get 0.8 minute for 1 mirror, in which we convert into second, it will become 48 seconds. Okay, so within 48 seconds, they will produce 1 complete mirror. Okay, they need to complete 1 mirror. So workers required, total operation time required. Okay, we have 140 seconds. Okay, 140 seconds for this all of the process. And we divide the takt time is 48 seconds. Okay, 48 seconds. That's the time they need to produce the what you call it, the mirror. And then we get 2.92 workers. So workers is a human, so we need to round up to 3. Okay, so we need, for this process, we need 3 workers. Okay, maybe you need 2 workers for assembly. Okay, and then the rest will do the, maybe you need 2 workers for these 2 process, and this one will be handled by 1 person. Okay, so you need to assign for this task. Okay, work balance chart. Okay, work balance chart. So you need to make sure that it's balanced. Okay, for example, for this process, they need 2.4 operators. So we round up to 3. And for this one, they have 4 operators. So you need to balance the work. Okay, for this one, the work is the task is very short. So maybe they need to combine this one and this one. Okay, so they need to make sure it's balanced. Okay, flexible and cross-train the employees. So make sure that all of these employees can do all the tasks. Okay, that's better. And machine bottleneck may require sometimes. Okay, maybe this one is the process is quite long, so maybe there's a queue for this process. Okay. For the work cell, they have 2 types. Okay, the first one is the focus work center. Okay, focus work center, in which they produce the parts. Okay, the parts for the door. And then the other one is the focus factory, in which they do the assembly. Okay, focus work center do the parts. Okay, and then focus work assembly, focus factory is more on the assembly of a whole car. Okay, this one is for the window. Oh, sorry, for the door. Okay. Okay, now we go to the last one, the repetitive and production oriented layout. This one is based on the product. Usually it involved with the product with the high volume. For example, this Coke bottle, and also for the automotive. And also for the this is for the metal sheet roll, okay, and this is for the washing machine assembly. So this type we call it as a repetitive and product oriented layout. The objective is to organize around product or family with the high volume and low variety. Okay, they cannot produce high variety like process layout, but for product they can go for high volume. Okay, and usually standardized product. For example, the same bottle, okay, the same size bottle, okay, or the same size model here. Okay, product oriented, it can be a fabrication line in which they building the component, or assembly line. Okay, they put the things together. Okay, these are the product oriented advantage and disadvantage. Advantage, they can produce a very low variable cost, in which that cost per unit is very low because they use machining, automation, and they produce in a high volume. And then low material handling costs because they mostly using conveyor belt. And then they reduce work in progress or work in process inventory because the process are in sequence. And easy training and supervision of the workers, and it's a very fast or rapid throughput. The disadvantage is that uh, be careful because it's very high volume, so you don't want any machine breakdown, because if one machine breakdown, the whole line going to stop. Okay, work stoppage at any point. So that's the dangerous of or the disadvantage of product orientation layout. Okay, and it's lack of flexible. If you want to change the bottle size or you want to change the design, it will take a longer time to switch. Okay. Okay, if you look at this diagram, it shows that this is at the variety, these are the volume. So fixed position is the one with the very low variety, it cannot handle many models, and the volume is very low, only one at a time. Process layout is have a high variety, but the volume is low. Cell layout is in between, and product layout is low variety. They cannot produce many type, but they can go for high volume. Okay, so if we put all four together, these are the advantage and disadvantage. So each layout have their own characteristic, and also have their own disadvantage. Alright, so for next video, I'll show you on the lines balancing calculation.